Have you ever used one of those new crypto apps and wondered how they let you log in with just your email, but still promise, top-notch security for your assets? There are no scary 12-word phrases to write down and hide under your mattress. So how is that even possible? Well, today we're going to dive in and uncover the really clever tech that makes it all work.
So, to really get where we are now, we have to take a quick look back at where we came from. Because honestly, the entire experience of using a digital wallet has gone through this massive revolution. It's gone from clunky and kind of intimidating to something that's sleek and almost invisible.
I mean, remember the old days? Come on, you had to install a separate browser extension, create a wallet, and then you'd be frantically writing down a 12 or 24-word seed phrase, absolutely terrified you'd lose it. The new way? It feels just like any other modern app. You log in with your email, maybe your Google account, and a wallet is just there. It's intuitive, it's totally integrated, and it's just so simple.
And that brings us to the central question. This is the big puzzle we're going to solve. How can an experience that feels this simple possibly be as secure, or, get this, maybe even more secure than the old way? The answer, it turns out, is surprisingly elegant.
Okay, so the secret sauce here lies in a huge shift in how we even think about a private key. Instead of treating it like this single, precious object you have to hide, this new approach says, hey, the safest key is one that never actually exists in one piece to begin with.
It's a concept called distributed key sharding, and the best way to think about it is like a treasure map, right? Instead of having one map that a thief could just grab, you immediately rip that map into two pieces, you put each piece in a different high-security vault, and then you burn the original. One piece of that map is completely, totally useless on its own.
And this process is what's so fascinating. A brand new, completely random key is generated. But, and this is the wild part, it only exists for a fraction of a second. It is instantly shattered into these encrypted pieces or shares. Those shares get sent to totally different, secure locations. And then, this is the most crucial part, the original complete key is permanently destroyed. It is gone forever. It never, ever persists.
So, if the key is always in pieces, where do these pieces meet up to actually do their job, like signing a transaction? Well, they need an ultra-secure meeting place, a kind of digital fortress that absolutely no one can get into. This quote from the source material really just nails it. The key parts are only brought together for a brief moment inside something called a trusted execution environment, and only when you, the owner, give the command. So what is a trusted execution environment, or a TEE? You can think of it as a black box for doing math. It's a hardware-isolated section of a server, like a vault, that's guaranteed by the processor itself to be completely sealed off from everything else. Not even the company running the server, like Amazon, can peek inside. No one. And this is exactly why it's so secure. Inside this digital vault, there's no way to store data long-term. There's no connection to the outside internet. There's no way for a human, any human, to log in and poke around. It has one job and one job only. Run a tiny, verified piece of code to sign your transaction, and that is it.
All right, let's get into the nitty-gritty and see how all this builds a complete security system. It really all comes down to a very simple two-part recipe for your key. The model is what's known as a 2-of-2 system. All that means is there are two shares, and you need both of them to do anything at all. If a hacker manages to steal just one of them, they have literally nothing. It's just cryptographic gibberish without its other half. So here are the two pieces of our treasure map. The first is the auth share. This piece gets unlocked when you successfully log in with your email or social account. It's basically your proof of identity. The second piece is the enclave share, and that one lives permanently inside that super secure TEE vault we were just talking about. And here is how it all comes together. It's like a little security ballet. When you want to make a transaction, you hit approve in the app. That sends your unlocked auth share on a quick trip to the TEE vault. Inside the vault, for the very first time, it meets the enclave share. For a millisecond, the full key is put back together in secure memory, it signs the transaction, and then it's wiped from existence. Poof, gone. The only thing that ever leaves that vault is the signature itself. The key is never, ever exposed.
Okay, I know, that was a lot of technical detail. But what does it actually mean for you as a user? Why go through all this trouble? Well, the benefits are actually pretty simple and incredibly powerful.
First off, this isn't just some theory in a lab.
This exact architecture is already out there, it's battle-tested, and it's securing over 75 million accounts for some of the biggest apps in the space. We're talking Farcaster, Zora, and Blackbird. This is built for the real world, at massive scale.
So, the bottom line is this. You get a system with no single point of failure. A hacker can't steal a key that isn't even stored anywhere in the first place. You get true user control because your login is one of the two mandatory pieces of the puzzle for any action. And you get all of this intense security wrapped up in an experience that is just unbelievably fast and simple.
Which kind of leaves us with a final thought to chew on. In a world where we're always trying to hide our most important secrets, maybe the best way to protect a secret is to make sure it never truly exists in one place at all. It's a radical new way of thinking about digital ownership, and believe it or not, it's already here.